In this video, we're going to look at predicting acid-base reactions using something called the five-step method. So a typical question you may see is, what is the predominant reaction when solutions of sodium hydrogen carbonate and nitrous acid are mixed? So to start this, we're going to list all species that are present. So because we have solutions, we always have water. We have nitrous acid, which is HNO2. This is a weak acid, so we don't dissociate it. We have sodium hydrogen carbonate. The sodium hydrogen carbonate will dissociate into sodium and then into hydrogen carbonate. So these are the four species we have present, and these are the only four species that we can use for our reaction. So once we've identified all of our species, I'll just list them again. We're going to identify any acids or bases from our list. Some species may be both acids and bases, some may be neither, so they're just spectator ions. So looking at this list, you can use the table in your book for this if you'd like. Our acids include water, nitrous acid, and hydrogen carbonate. And our bases include water, so water is amphiprotic, and hydrogen carbonate is also amphiprotic. Sodium is a spectator ion, so it is neither an acid nor a base and will not be involved in this reaction. Once you've identified our acids and bases, we're going to find our strongest acid and our strongest base present. So I'm just going to list one more time. Our acids include water, nitrous acid, and hydrogen carbonate. And our bases include water and hydrogen carbonate. The strongest acid is going to be the acid with the highest Ka value, closest to the top of the table. Our base is the strongest base is going to have the highest Kb value, and now Kb values aren't listed, so you're going to be looking closest to the bottom of the table in that base column. So looking at our table, our strongest acid is nitrous acid, and our strongest base, I forgot a negative sign here, our strongest base is hydrogen carbonate. So our next step is to actually react that strongest acid and strongest base. So nitrous acid, aqueous, plus hydrogen carbonate. So nitrous acid is our acid. It's going to donate a proton, and it's going to form its conjugate base, which is nitrite. And then hydrogen carbonate will accept a proton, and it will form its conjugate acid, carbonic acid. So we have a proton going from our acid to our base. So we're almost done. We just need to figure out the position of our equilibrium. So is our equilibrium product favored or reactant favored? So I'm just going to write our reaction down again. All right, so what we're going to do, there's two ways to do this prediction. There's a kind of a shortcut, and then there's by comparing Kas. So we're going to start with the comparison of Ka values, and then I'll tell you the shortcut. The Ka for our acid in our reactants is 5.6 times 10 to the negative 4. The Ka for the acid in our products, so that's carbonic acid, is 4.5 times 10 to the negative 7. So these two acids are having kind of a shoving match with a proton. So nitrous acid is shoving a proton in this direction, and carbonic acid is shoving a proton in this direction. Now, the stronger of the two acids is going to win. So in this case, the stronger acid is nitrous acid, and it's going to have a net effect of pushing the proton towards the products. What that means is that at equilibrium, there'll be more products than reactants, and this would be a product-favored equilibrium. So our reaction percentage is greater than 50%, and we can say product-favored. Now the shortcut for this is to use your acid-base table. And you're going to take your left finger and you're going to put it on the acid from the reactants. So the acid in the reactants. And then you're going to take your right finger and you're going to put it on the base in the reactants. If your left finger is higher than your right finger on the table, it is a product-favored reaction. If your left finger is lower than your right finger on the table, it is a reactant-favored reaction, so less than 50%.